Welcome to Dr. P Maths, where we develop our coding skills by solving mathematical problems at GCSE A-level and beyond. Last time, when we looked at a mechanics problem on the tutorials, we only dealt with a case involving weights. There was no external forces. Today, we're going to look at a case not only with an external force, but an external source at an angle. So in this case, it's the tension force. So let's have a look at the question. A string is attached to a block of mass 4 kilograms, which rests in limiting equilibrium on a rough horizontal table. So let's have a look at some of this. The mass is 4 kilograms, so we know that. Limiting equilibrium means it's not moving, and at a rough horizontal table, which means friction is involved. The string makes an angle of 24 degrees above the horizontal, and the tension in the string is 30. Find the coefficient of friction between the block and the table. So the first thing you should always do is draw a little diagram. So I've already done one here in advance. Let's label them. So R is the reaction force. Here we've got the weight, which I just call mg, not wg. Okay. Now, on the left side, it's going to be mu r. And then here, the tension force, say, is an angle at 24. So let me just draw another line here to represent the plane. Put an angle here of 24. So before I proceed any further, I always like to resolve the forces first. So what I mean by that is that I'm going to draw a triangle and resolve horizontally and vertically the tension force. So let's do that now. Okay, so let's talk about how we do this. Now, if we picture a right angled triangle, of which this is, we know that the hypotenuse is 30, because that's the length. So then our formula is sine theta for a right angled triangle is opposite over hypotenuse. Now, if I went to rearrange for opposite, so we've got O and A here, I will simply do H sine theta equals O. And similarly for cosine theta. So cosine, so H cosine theta is equal to A. Now, in this case, we actually know two things. We know the hypotenuse, which is 30, and the angle, which is 24. So we can say 30 sine 24 is equal to opposite, and 30 cosine 24 is equal to adjacent. Cool. What should we do next? Well, now we're going to start resolving. And what we'll do, we'll resolve horizontally first. So I'll draw a little arrow, which is right, which is the horizontal plane. And the right arrow indicates that direction is positive. So in this case, it's adjacent minus mu r is going to be 0. So adjacent is equal to mu r. And we already know the adjacent, it's 30 cosine 24. So 30 cosine 24 is equal to my mu r. Okay. And now, how do we find r? Because we've got one equation, but we've got two unknowns here. So let's resolve upwards. Okay, and we're defining up as positive. So it's going to be r, which is positive. But also what else is positive is 30 sine 24, because the arrow is going right and up, as in the tension force arrow. That indicates that. So then we get 30 sine 24, and that is going to equal mass times gravity. So we already know the answer. That mass is 4 and gravity is 10, so that's going to equal 40. Two equations, two unknowns, so we'll solve simultaneously. But in this case, it's probably easier just to substitute. So what we'll do here, we'll say 30 cosine 24 over mu is equal to r, and then put it into here. So substitute in. So then we're going to get 30 cosine 24 over mu. And what I'll do at this stage is I'll move the 30 sine 24 over to the other side. So that's going to equal to 40 minus 30 sine 24. And then a simple rearrangement, we'll just multiply by mu and then divide by 40 minus 30 sine 34. We're going to get the following answer for mu. So mu is equal to 30 cosine 24 divided by 40 minus 30 sine 24. And this will give us our answer. So if we substitute in, and this is in degrees rather than radians, we get our answer, mu is equal to 0.986. In the next part, we are going to apply this question to Python coding and create a routine that will solve not only this particular example, but similar examples involving tangent force at an angle.